So, we need to determine if the given point 1, 3 is a solution to the equation given, y equals 5x minus 2. So there's actually two different ways that we can approach this, but because we were given a graph, we'll start with graphing this equation first. Now the thing that's nice about this equation is it is in slope-intercept form. That means we have our slope, our m value, our slope, our m, and our y-intercept b. So when we graph an equation in slope-intercept form, we always want to start with the y-intercept, which in this case is 0, -2. So I'm going to place a point for that graph, and then we can apply our slope here, which is 5. Now there's an understood fraction here. It's 5/1. So our rise is 5. 1, 2, 3, 4, 5, and over 1. And we can plot a point there. And we just want to keep that going. 3, 4, 5 over 1 as many times as we can in both directions. So when we go the opposite way, we're going to go down 1, 2, 3, 4, 5, but to the left 1. 1, 2, 3, 4, 5. It'd be somewhere down in here. And once we have those points, we can connect these to make as straight of a line as possible. All right, it'd be nice if you had a straight edge. I don't, which is why my graph is really wobbly there. So then we have to determine, is the point 1, 3 a solution? So we're going to find, where is 1, 3? So we're going to go over 1 and up 1, 2, 3. So here is the point 1, 3. And we want to know, did our graph cross that point? Well, it certainly did. So that would mean that the point 1, 3 is indeed a solution. Now, at the beginning, I said there were two ways that we can do this. If you really like to graph and the equation is in slope-intercept form, by all means, graph it and see if it's a solution. But maybe you don't like graphing, or maybe it's not in slope-intercept form. So there's another way that we can actually do this algebraically. So we're going to take the equation that we were given, y equals 5x minus 2, and then we're going to substitute the information, the value that was given to us. So we know that our x value is 1. So anywhere in our equation that we see an x, we're actually going to change it and substitute in the value of 1. If I can find my pen, there we go. So instead of an x, we are going to substitute the value of 1. We were also told that we have a y value of 3. So anywhere that we see a y, we're going to substitute in a 3. So we can come in here and keep the rest of it the same. So 3 equals 5 times 1 minus 2, and now we're going to evaluate. So there's nothing to do on the left-hand side of the equation, and then we have 5 times 1 is equal to 5 minus 2. Again, there's nothing to do on the left-hand side, so we're going to keep that 3 equal 2, and 5 minus 2 is indeed 3. We know this is a solution because what is on either side of the equal sign is indeed equal. 3 is equal to 3. So algebraically, we have confirmed that 1, 3 is a solution to the equation y equals 5x minus 2. Let's look at one more example. So here we have the equation y equals -1/2 x plus 8, and we are asked if the point 0, 7 is a solution. So there's something interesting here about this point. When we have a 0 for the x, this is what we can call the y-intercept. So there's actually 3 ways we can actually solve this one. We can take the time to graph the equation, we can check it algebraically, or we can just identify the y-intercept from the equation. And here we know, because it's in slope-intercept form, y equals mx plus b, we know our slope, our m, and our y-intercept b. So here we see that the y-intercept is going to be 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Is that equal to 0, 7? No, it's not. But let's go through this and double check and make sure that it does indeed not work if we finish graphing. So we know that our y-intercept was 8. Our slope is negative 1/2. So we're going to go down 1 and to the right 2. Down 1, right 2, as many times as we can. And then we'll go in the opposite direction. We're going to go up 1, left 2. Again, as many times as we can. And then we would want to connect these with as straight of a line as possible. Again, if you're doing this on paper, hopefully you have a straight edge. And so let's look. Let's find the point 0, 7. Count 1, 2, 3, 4, 5, 6, 7. Well, that's the point right here. We can see that our line does not touch. Now, let's also check this algebraically. Again, just want to confirm that what we've done is correct. Just another way to do this. You don't have to do all of these. You just want to pick the one that makes the most sense to you. And so, oh, it's not a B, that's an 8. Fix that. And so we want to substitute in the information we were given. We were told that our x value is 0. So anywhere in our equation that we have an x, we're going to put in substitute a 0. And we know that our y value is 7. So anywhere we see y, we will substitute in that value of 7. And then we're just going to copy down the rest of our equation before we solve. Again, nothing to do on the left-hand side, but now we have negative 1/2 times 0. Anything times 0 is 0, and then our plus 8, and 0 plus 8 is 8, but 7 is not equal to 8. So this again confirms that the point 0, 7 is not a solution. Let's look at one more example just for good measure. So here we have the equation y equals negative x plus 4. We're going to start with our y-intercept, or identifying our slope and our y-intercept. So we know our slope is what's in front of the x, the coefficient of x, and there's an understood 1 in front of here. And then the constant is our y-intercept, or b. So our y-intercept here is 0, 4, so we can plot that point, and then we're just going to apply our slope, a negative 1, so we're going to go down 1 and to the right 1 as many times as we can. And then we would continue in the other direction as well, going up 1 and to the left 1. And then we want to connect these with as straight of a line as possible. Again, if you're doing this on paper, that's a little bit easier for you to work with. So imagine there's a straight line in between these. So now we have to just identify where is the point 2, 2. So we would go over 2 spaces from the origin, and then up 2 spaces, which puts us right here. And it certainly looks like our graph crosses at that point, so we can say yes. But let's confirm algebraically just to make sure. So y equals negative x plus 4. Again, we're going to take the point that we are given that we know for x is a 2. So anywhere we see an x, we will substitute a 2. And we know that our y value is also a 2. And then we're going to keep the rest of the equation the same. So we're going to bring down the equals, the negative, and the plus 4. There's nothing to do on the left-hand side. And on the right-hand side, all we have to figure out is what is negative 2 plus 4. Well, that's 2, and 2 is equal to 2, confirming that this is a solution. Great job, guys.